Hey, wonderful students. Here's a series of videos that's going to go over your midterm review. I created a bit.ly link for you if you need access to that if you're not in my class. This is going to be covering the first 7 chapters in this textbook. So if you happen to be using this textbook, it should follow right along with that. I'll have page numbers included on the book for you to reference if you need it. There's going to be 7 videos. This first one is just going to go right in order of the chapters, so chapter 1 through 7, and it's also in the order we learned our units. Chapter 1 is dealing with one variable data, specifically categorical and quantitative, and analyzing it. If you would like to write any of this down, pause the video. I'm not going to go over the terms. I'm just going to get right into the problems. Here's the first question. Realtors collect data in order to serve their clients more effectively. In a recent week, data on the age of all homes sold in a particular area were collected and displayed in this histogram. Shown below here, you have a histogram, age of home as the X variable, frequency as the Y variable. You're asked to write a few sentences to describe the distribution of the age of these homes. You may want to pause this video and try it on your own. Just a reminder, you may want to remember your SOCV, shape, outliers, center, variability, also include context in the problem. Here's my solution. I said the distribution of home ages is skewed to the right, with the center at around 15 to 25 years. The range of the data is between 5 and 75 years old, with a potential outlier between 70 and 75 years old. That covers all the bases here. I have my shape, which is skewed to the right. I got my range, which I don't really know the specifics. I don't know if 5 and 75 are actual numbers, but I know that between 5 and 75 is going to be my range. And I didn't bother really counting the numbers. I just estimated my median to be somewhere right in there. And anytime you're talking about the center, generally speaking, we're talking about the median. That's about all. So let's look at question number 2. Question number 2 is dealing with the same data. It says, how will the mean age of these homes compare to the median age of these homes? Anytime you have right skewed data, well, skewed data in general, the mean is always going to be in the direction of the skew. So if the data is going to be skewed to the right, then you would expect the mean to be somewhere over here, whereas the median is going to be a little bit less. So you might see the median here and the mean over here. Can't spell mean apparently. So we would expect the mean to be greater than the median. This is what I wrote. Since the data is skewed to the right, the mean will be larger than the median age of these houses. I still include context in the problem just to make sure I'm covering my bases there. All right, let's go on to the next question. Part C, one of these homes was originally reported to be 25 years. It is actually 50 years old. So whoops, typo. What effect does this increase have on the following statistics? Justify your answers. So the mean, if I take a number that's smaller and bring it way larger, it's going to affect the mean. It's going to make that mean bigger. The median, since the median we know is going to be somewhere over here anyway, and that number is already going to be bigger than median, I wouldn't expect that median to increase at all. So this is what I wrote. For the mean, I said the mean will increase since a higher value will be averaged in. For the median, I said increasing this age from 25 to 50 shouldn't impact the median since it's most likely already above the median to begin with. Moving on to the next question. Make sure you're writing these down too. Question 2, the 5-number summary for a data set is given by min 12, Q1 38, median 46, Q3 50, max 66. Part A, determine if there are any outliers, show work, and explain your reasoning. You're going to want to use the 1.5 IQR rule. Remember how to do that. Pause the video and see if you can try to figure out if there are any outliers on here, and I'll show you how to write it up. All right, I have the work here. Let me walk you through what I did. So as far as the 1.5 IQR rule goes, you want to first get the IQR, which is Q3 minus Q1. So take your 50 minus your 38, and you're going to get 12. That's your IQR. Then take that number and multiply it by 1.5. 1.5 times 12 is going to give you 18. That's the number you're going to subtract or add for your quartiles, depending on which end you're at. So if you're on the low side, subtract that from Q1. Since Q1 is 38, 38 minus 18 is going to give you 20. That means anything below 20, less than 20, is going to be considered an outlier. Since I have a minimum of 12, 12 is going to be an outlier. There could be other outliers as well. Anything below 20 would be considered an outlier, but I know at least 12 would be considered one. Similarly, if I do Q3, which is 50 plus 18, that's going to give me 68. Anything above 68 is considered an outlier, but my maximum is 66. So since I don't have a maximum higher than that, I'm all set on the high end. I don't have any outliers there. So my final statement says, since the minimum is 12 and the max is 66, there is at least one low outlier, no high outliers. I did not say there is an outlier at 12. I just said there is at least one low outlier, and I have my work to support that answer here. On to the next question. What would be the maximum possible length of the left side whisker on a box plot of this data to show that any outliers exist? Okay, so this is kind of an awkward question to answer, but let's go through it. So what I said was anything below 20 is considered an outlier, right? That means the whisker must end at 20. Its biggest length would have to be somewhere between that minimum value of the whisker and 38. It makes more sense when you actually see a box plot with numbers to kind of answer this question. So if you have to draw a box plot, that's probably a good idea, but that answer will be 18. And let me show you on the next problem where that kind of thinking comes along, okay? So suppose the lowest three values in the data set were 12, 16, and 20. Neatly draw and label a box plot of this data in the space below. Which means if 20 is down there in the bottom three, but 20 is not considered an outlier since it's not less than 20, that's going to be where the whisker cuts off when you draw your box plot. You're going to have dots at 12 and 16. So it's going to look something like this. Take a moment to write that down. And I can label this just to give you some numbers here if that helps. I know that this is going to be about 12, and I approximated it, but here's 12, 16, 20 over here. And this one I estimated to be about 38, which is Q1, 46 for the median, 50 for Q3, and your maximum at 66. Now, this might help you answer this question. This is going to be the biggest that whisker could be, 20 to 38, if I have outliers below that. So 18 would be considered the maximum length that whisker could be, and that kind of helps reinforce the box plot down below. So that concludes question 2. Write anything down here that's helpful for you, and let's move on to the next question. That's actually all the questions I have in terms of chapter 1 review. So I'll end this video here. The next video is going to be talking about chapter 2, which is still unit 1, but it's the second part of unit 1 in the course sequence. Thanks for watching.